Okay, this is going to be a video lecture on environmental problems, their causes, and sustainability. Now, before I go into this, a couple of things for the notes that you should be made aware of. If it's typically in a yellow color, that means that we need you to highlight it. If it's in a green color, it's there for reference. So whether it's green lettering or a green background, you don't need to write anything down. It's just something that we want to point out to you. Now, you'll probably notice that the video version has a lot of things that we may have shown in class that have been excluded from the presentation. That's simply because some of the things that we show in class we need to discuss with you in class. We're going to skip activity slides or certain green screens that we're not going to include in the video lecture. The video lecture is intended for people who are absent and were not there to hear the presentation, or you've already heard the presentation and you didn't understand a concept and you would like to go back and listen to it one more time. This is not to be used in place of every single lecture. The video notes are about 80% as good as we are live. So it's important to be in class, be engaged in the lecture, and use this to supplement when you are absent. With that being said, let's move forward. So we started off with exponential growth, and the reason I have this here, normally we won't have a green screen, is to point out, again, if you see this green stuff, you won't see it anywhere in the notes. You don't need to write it down. This is what we did start off with. We started off by looking at exponential growth and how we have grown as a civilization. So starting off at maybe to 5 million years ago, when we hit the agricultural revolution, we see a small growth spurt here. At some point in time, we hit the Black Death. We see a decline in our population, and then we see a spike again with the Industrial Revolution. Currently, we're somewhere around the 7 billion mark. We're not entirely sure as to what our limit is, whether that be 8 billion or 10 billion. But we'll get into that once we get into population. So, environmental science. What is it? Well, it's really about the study of our connection to nature. And it's an interdisciplinary study, so we're going to pull from a lot of different areas, whether that's a previous chemistry class, a previous marine biology class, a previous chem course, any science class you've taken, physiology. We can all use bits and pieces of that and somehow fit it into environmental science. And really what we're focusing on are natural sciences with an emphasis on ecology. Now we are going to include some social science issues and some humanity issues. So we're going to be looking at history. We are going to be writing things in here like an English class. So this includes and encompasses a wide variety of other areas. So what is our focus in class going to be? 1. How does nature work? And while that might seem like an easy, oh, that's just going to be our focus, it's a complicated issue. There's a lot of things going on. How does the environment affect us as human beings? How do we affect the environment? How do we deal with our environmental problems? There are no easy answers, so we're going to have a couple of debates, some disagreements about how we're going to deal with these things. And finally, how to live more sustainably. And in terms of sustainability, we'll get into what that is in a couple of slides. Human well-being, though, really does depend on us maintaining a sustainable practice, which we're not very good at right now. Now, sustainability really is how do we use our resources without depriving them from future generations? How can we use what we have on this planet and not completely waste it so that there is something left for generation after generation after generation? Because right now, we're not doing a very good job of that. We tend currently to consume a huge amount of resources, and it doesn't look like there's going to be much left for future generations. We're also going to focus on sustainable development, because we have to balance out economics with our well-being. The truth is, some of you guys are going to go into business, and you're going to have to balance out making money with being sustainable. So how do you make sure that you're not completely mining everything out of an area, whether that be trees or minerals, and still make a profit? Keeping in mind, like I said, we need to manage our resources for future generations. So, sustainable practices. The environment shouldn't be damaged beyond its ability to recover. And again, we don't do a very good job of this. We do a good job of damaging it beyond its recovery. Also, we got to make sure that renewable resources, and I'll get into renewable resources in a little bit, they shouldn't be depleted or used faster than they can regenerate. Think about a forest. We probably shouldn't chop down an entire forest completely clean. If we pick and choose places and spots and let some parts grow while we chop down others, maybe we can manage that a little better. We do have to be careful with this last one, non-renewable resources. These are resources that once they're used, we're never going to get them back. Oil is a great example of this. Oil will not last us forever. We act like it does, or it will, but it will not last us forever. So we need to use it when we need it. So there are 3 resource types. One is inexhaustible. Solar energy is a great example of this. We're never going to run out of this stuff. Wind energy is another great example. Hydroelectric is another great example. Renewable means that we can use it, but it's going to take a couple of hours or a couple of decades to get that back. Again, think trees. We can cut down trees, use those. They can grow back in a couple of decades. The last one, exhaustible resources, meaning that there's only a limited amount. Once we use them, gone. It'll take thousands or billions of years to renew. Think oil. Oil is not made in decades. It takes thousands, millions of years to create fossil fuels. Now, this is just an example. This is inexhaustible. Again, plenty of wind, plenty of solar. It's not like wind is going to completely stop and never be available again. Same thing with solar. It's always going to be around. This is an example of a renewable resource. Can we cut some trees down, let them grow, cut some other trees down, let them grow? Yeah, but we shouldn't be chopping down entire forests. Now, this is an example of a non-renewable resource, fossil fuels. Once we use it up, it's gone. Now, again, just some more examples of renewable resources: forests, grasslands, fresh air, soil. Even soil, you might think, well, there's a lot of dirt. Yeah, but if we use it and we take out all the nutrients, it doesn't really do a whole lot of good. We need to be careful how we use our soil. Sustainable yield is an important concept, so you might want to highlight this here. It's how much can you use without reducing its available supply. Again, think that this thing doesn't last forever for us. How can we use some of it, but not all of it, so that we allow for new growth and we can keep harvesting over a long period of time? Another concept you're going to need to know is environmental degradation. This is when we begin to reduce our supply and it doesn't have time to renew itself, meaning it's going to run out. For example, exhaustible resources is a great example of this. We're going to use it until it's completely gone. Some forests, we're going to wipe them clean, okay, and then there won't be anything left. So that's called environmental degradation. Just wanted to point out some resources, again, that are not renewable, so we're clear as to what they are. Once we use them, not likely to appear again. Examples of energy resources: oil, fossil fuels. Once we extract all the fossil fuels out of the ground, that's it. We're not going to get them back. What about metallic mineral resources? There's a fixed amount of gold in the earth, a fixed amount of iron, a fixed amount of aluminum. Once we pull all of that from the ground and mine it, it's not going to be back in a couple of years. Gold is not going to magically reappear in 10 years. It's going to be a really long time before we see that again. What about non-metallic resources that are gone? Helium. If you don't know this, we're running out of helium for helium balloons. Once helium runs out, that's it. It's gone. We're not going to get it back. So how are we able to conserve? What can we do to prevent us from wasting everything? Well, we can reuse. When it's possible, don't throw stuff away. Reuse it a couple of times. Plastic water bottles are a great example of this. Instead of buying single-use water bottles where you use it and you toss it, buy a reusable water bottle. You can wash it, put more water in it, and it'll be fine. Refuse. Don't buy things like disposable single-use water bottles. I know it's convenient. I know they sell them in huge packs at Costco, but it's probably better if we try to stay away from those sorts of things. Reduce. If you are going to buy plastic, try to limit the amount of plastic you're going to buy. And we'll get into plastics later on. Recycle. If you do use some of these products, try to recycle them, whether it's aluminum, glass, or plastic. Later on, we'll talk about the realities of recycling. Now, of course, and we're going to be taking a look at something like this, it depends on where you're at. Some people are really good at reusing what they have and limiting the amount of things that they use because they don't have the money or the luxury to go out and buy huge quantities of single-use water bottles like we do. So they have to get creative in reusing things and recycling things. Some nations who are a little better off can buy more things just because they can. Now, this is a super important concept. So important, I'm going to have you highlight it. So, the idea of tragedy of the commons. Now, this is a very famous article that some of you may have read in another science class. Now, everybody thinks that commons is a place. It's not a place, rather, it's an idea. The idea of a commons is some sort of natural resource or area that a lot of people are sharing. So just think about a city or a forest or a fixed amount of water. Those are all things that we call commons, again, natural resources or areas. Now, when we talk about tragedy of the commons, which again is an article that you're going to read, but it's more of a concept, it's this idea that if you do not put some sort of regulation, whether that be a law or an act, that individuals are going to take advantage of the commons, they're going to take advantage of the natural resource or the area, and use it to their own advantage because it's there. They're not going to care so much about the generation that comes after them or the people that are around them. They're going to use it for themselves. Usually, they're going to use it without imposing a limit on themselves. What will happen is they'll use up all the resources, they'll take everything out of the area until it's completely gone or ruined. This is an important concept on the AP exam. This is why, for the most part, people believe we need certain laws, regulations, and acts to prevent people from misusing commons. And we know this is true because our ecological footprint is growing. All an ecological footprint means is how much are we using per person over a given area of land. And we'll do an activity in class to show you this. Kind of tied to this is the idea of what we call biological capacity. And it's the idea that an area can kind of keep giving us a continuous supply of renewable resources. Again, a forest, a number of organisms in an area. So whether it's cows or goats or whatever, what's the biological capacity? How long can it keep supplying us with this renewable resource? So long as we don't misuse it. Now, because of changes in culture and advancements in technology, our ecological footprint has increased drastically. 1,200 years ago, we were a hunter-gatherer. culture. But 3 major events happened. And you notice we don't put the dates on here. It's really important you understand why we're not going to worry about the dates. We're going to talk about it in class. But there are 3 major cultural events that you need to know that have impacted our growth in population. One is the agricultural revolution, how much food we were able to produce. At some point, instead of just going out and gathering, what we could find, we started planting food. We started growing food to sustain ourselves. This helped increase our population size. Then came the industrial medical revolution, somewhere around the 1800s. Now, we are now able to mass produce things, and we come up with new innovative medicines, which increases our lifespan, which also increases our population size. And finally, the age that we're in now, which is the information and globalization revolution. We have been able to grow as a population because we know more now than we ever had before. Information, because of the internet, is out there, and ideas about medicine, farming are accessible to anyone who has access to the internet. So now we have even more resources available, or ways to extract those resources available to people out there in the world. Now, there are 3 property types, like who owns what. So after all this resource talk and this person's getting from here and that, who owns it? There's 3 types of properties you need to know about. Private property, which kind of is self-explanatory. It's private. It's owned by someone or a company. You can't touch it. No one else can. Only that company or that person. There's also common property, something that's owned by a relatively large group of people or individuals. So, small city. And then there's the open access renewable resource. And this is owned by no one and is available for use by anyone, with basically nobody charging you a thing to go and use it. The ocean is a great example of this. If you go off the coast far enough, there is no law, there is no act that says how much you can pull from the ocean. Now, there are laws that say how much you can bring back to shore in certain places, but as far as catching out there, no real limit, no real body of government that says this is how much you can catch when you're out in the ocean. So this is just kind of a generalized cartoon here. Forest turns into our timber and paper, cropland, our food, fisheries, our seafood. So as we've grown in size, as the population of the earth has grown, so has our footprint. We're using more energy. We have more settlements. We're using more timber. We're eating more food. We're taking more out of the ocean. So what is pollution and what can we do about it? Believe it or not, preventing pollution is going to cost us less and is more effective than polluting the environment, because it means that we have moved towards sustainability. We have found a way to make sure that this can exist over a very long period of time and it's not going to run out on us, versus getting something, using up all the resources, and creating a lot of pollutants. Now, pollution has this long term here that you can see. I'm not going to read it to you. You're not going to use that particular word on the AP test. We'll explain why. Again, it's super important that you do not just write down the word pollution on the AP test. That is not enough to get you a point on the AP test. And you can kind of read this stuff in green. It helps explain why. Now, where does pollution come from? Well, sources of pollution are what we call point and non-point sources of pollution. Point pollution means it comes from a very specific place, like a smokestack. And I'll show you a picture of this in just a second. Non-point means it comes from a generalized area. And there are 2 types of pollutants. One is called biodegradable. It's a pollutant that's out in the air, and over time, it's going to be reabsorbed back into nature. Typically, this is done by bacteria. Paper, cardboard, napkins that you see out on the street. At some point, they're going to break down and go back into nature. Now, there are some things that are non-biodegradable. They will not break down over time. For example, mercury. Mercury will not break down over time. It will always be mercury. Plastics, if you don't know this, last a really long time. They last about 500 years, depending on what type of plastic you're using. Most people think plastics are going to go away in 10, 15, 20 years. No, they're going to be around longer than you are. So what can we do to clean it up or prevent it? In terms of pollution cleanup, just being very generic right now, we need to control our output. In terms of prevention, we need to control what we're putting in. And again, we're going to get into more details of this later on. There are 5 environmental indicators. Basically, these are 5 things we look at to see how the environmental system is doing. The first one we're going to look at is biodiversity. In short, how is the life in the area, different life forms, organisms, how are they doing? Now there's 3 things we look at: genetic, species, and ecosystem. In biodiversity, in terms of genetic diversity, we're looking at how much genetic variation there is amongst the individuals in the population. Do we have high genetic variation, which means we're doing well, or do we have low genetic diversity, which means we're not doing so well? Species diversity, this is just the number of different kinds of things in the area. Do we have a large number of species in the area, or don't we? Ecosystem diversity. What's the diversity of the ecosystem or the habitats in a given area? If we go to an area and it's all desert, there's no life growing there, then we're not looking so hot in terms of biodiversity. Indicator number 2, food production. Do we have the ability to produce enough food/nourishment for the human population? Can we use science and technology to increase that food to produce for the human population? So that's indicator number 2 of how well the environment is doing. Number 3, so this is indicator number 3, surface temperature and CO2. To see if the environmental system is doing well, we have to monitor how warm it is and how much CO2 there is in the atmosphere. Now, CO2 is going to be the most significant greenhouse gas that we're going to talk about. One other word that you're going to need to know is anthropogenic. This means that it's derived from human activity. It's caused by humans. CO2 is not only caused by humans, but we do create CO2. The CO2 that we do create is anthropogenic. And again, we can just see concentration of CO2 across temperature. We will talk more about this graph. Indicator number 4, human population. So how well is the system doing? Well, we have to take a look at how many humans are on the planet. Currently, we're about 7.2 billion. We're growing. I'll show you the clock that gives us an estimate. Population scientists, we talked about this in the quick write, that we're going to reach anywhere between 8 to 10 billion people by 2050. And they think by 2100 that number is going to stop. But that might change depending on advancements in technology, medicine, and have we used up all our resources? Again, we'll be taking a look at this graph in terms of human population later. Finally, environmental indicator number 5. So how well is the system doing? Really, it's all about this one down over here. As we grow, we're placing more demand on resources that have the potential to run out or will run out. For example, aluminum, copper, if we do a good job, maybe we can recycle enough of it to keep using it over a long period of time. Things like oil, coal, once we use them, they're gone. We're not going to see them again. I want to go back to this slide and look at the definition again. So this helps us describe our current state of the environmental system. The 5 things we will be paying close attention to. Biological diversity, again, we're talking genetic diversity, species diversity, ecosystem diversity, our food production, our ability to produce food for humans. The other thing we're going to be taking a look at, how is our environment doing? Let's take a look at global surface temperatures and CO2 concentrations. How else are we going to know how well the environmental system is doing? How many people do we have? The more people we have, the more resources we need for them. Resource depletion is another thing that we're going to look at. How are we using those resources? How are we managing those resources? Are we using them up? Are they all gone? These will be some of the things that we'll take a look at here in AP Environmental Science.